The main aim of our project is to address worldwide flooding with an effective, versatile solution.
We designed a flood barrier that uses the flood's energy to raise the barrier itself, protecting the infrastructure and civilians behind it. To optimize the effectiveness, we wanted to ensure that our design could be adapted to different circumstances.
Our design is capable of being applied to various locations and situations, such as overflowing rivers, promenades, and surrounding vulnerable buildings and homes.
The main principle of our design is to protect from flood devastation, which is currently an ever-increasing problem due to climate change.
We created a model to further explore the workings of our design using second-hand plastics. Firstly, we experimented with different materials to investigate the buoyancy needed for the barrier in our model.
This investigation led us to consider the use of recycled plastics in a real-life barrier.
As the water level rises, this pushes the barrier up and against the runner, protecting the cardboard house from being flooded. Using a catch to keep the erected barrier in place allows it to lower again automatically when the floodwaters recede, enabling access when the flood is over. We met a few challenges in making our model, as everything had to be cut to a specific size to fit the container we were working in. Everything also had to be sealed well to keep it watertight, so that no water would leak through to the other side. In our model, we had runners up the sides of the container so that our wall could slide smoothly up and down. However, this was not very watertight, and in a real-life situation, we would use a seal to prevent the water from getting through to the other side.
The density of our barrier must be less than that of water, which is 997 kilograms per meter cubed, so it can displace enough fluid to create an upthrust that will support its weight. For example, polypropylene in many plastics has a density of around 900 kilograms per meter cubed, and so recycled plastics can provide a sustainable solution for the main composition of our barrier. Flooding has accounted for almost 50% of all worldwide weather-related disasters since 1995, leaving buildings damaged, people injured, millions homeless, and causing numerous fatalities. As well as this, flooding has lasting effects on the ecosystem surrounding the affected area. This drove us to design a flood barrier that would not only protect buildings, infrastructures, and lives from harm, but would also be somewhat affordable, eco-friendly, and potentially life-saving.
The versatility of our design means it could be applied to various locations, such as riversides, promenades, and around structures or homes. In applying our design to areas known for major flooding, we could widen the bottom of our barrier to withstand the larger pressure acting near the bottom.
As many of us should know, for several years, in an unfortunate attempt to generate an income, wealthy, seemingly smog-free countries have shipped tons of rubbish and recycling to poorer countries like Indonesia that have to deal with the issues of the unauthorized burning of British plastics every day. Since Indonesia is a country with several low-lying coastal cities at risk of being submerged due to flooding and climate change, we think that those plastics could be utilized for our barrier.
The main barrier could even be created by welding oil drums together, as these materials are readily available. This offers an even easier, more economical and eco-friendly way for developing countries to have protection against flooding. Our design is only limited by the access and funds to manufacture and build the parts, and even those are relatively cheap. The adaptability of our design means it could be applied globally to decrease flood damage and save lives. We really wanted to address this global scale problem in our project.
Thank you for watching and hope you enjoyed.